All right, number 20, we want to find the limit of the trigonometric expression. And it looks like we will need to use a double angle formula to be able to solve this one so that we can divide out, because again, if we plug in x, we will get 0 as the denominator. So I'm going to go to our course and go into videos, and we're going to pull up our trig cheat sheet and handouts. And we are going to look for the double angle formula that would help us in solving this expression. So when we have sine of 2 times the angle, we can write that as 2 times and then sine of the angle, cosine of the angle. And so we'll use this double angle formula to help us solve this expression. So we're going to start here. And we're going to find the limit as x goes to 0 of sine 2x, so x is our angle, over 19 times sine of x. Alright, so we're going to use the double angle formula. We're going to rewrite this as 2 times sine of x cosine of x divided by 19 times sine of x. So at this point we can divide out the sine of x, and then we're going to start to use direct substitution. So we'll have 2 times cosine of 0, and then we'll just have that over 19. And then if you think about your unit circle, 0 is here. The ordered pair is 1, 0, which is x and y. The cosine corresponds to the x coordinate. So this just gives me 1. So we're looking at 2 times 1 divided by 19, which just gives us 2 over 19 as our limit once we evaluate it. And then number 21, our final one, we have another trigonometric expression, and we're going to use, looks like maybe a Pythagorean identity. These ones I have more committed to memory. So we have cosine of x minus 1 over cosine cubed of x minus 1. So we're going to be using our cubic formula, and we'll factor out and then we'll go from there. So just as a reminder, when you have a cubed, I'm just using the generic formula, a cubed, and it could be plus or minus b cubed. Okay, the formula for factoring that would be to remove the cube. So you take the cube root and you keep the same sign. So the acronym we're using is SOAP, S-O-A-P, and that stands for same, opposite, always positive. So the first set would be the 2 terms. And again, if it's plus or minus, you use the original sign. So you have a plus b or a minus b. And then you get your other term by squaring. So this will be a squared. So that's the same sign, opposite sign. So whatever was on the top, it was plus, it would now be a minus. If you were dealing with the minus, it would now be a plus. So you just kind of keep the same order. Top signs go together, bottom signs go together. So you square it, you multiply these 2 together, and that will give us a b, and then you square the last term. So it don't matter if it's positive, you square it as positive. If it was negative, you square it as positive. So the same opposite and always positive is dealing with the last term. So that's going to give us b squared. So you multiply, or you square, multiply, and then square. So we're going to apply that to cosine minus 1. So on the numerator, we're still going to have a cosine x minus 1. Now again, if I was to plug in 0, this would give me a 1. 1 minus 1 is 0. Same thing here. And so we have to do factoring. So this will give us cosine of x minus 1. And then when I square it, cosine squared x. And then we multiply these two together. So same sign. This next one's going to be opposite sign, so it's going to be a plus cosine x, because you multiply times 1, it stays the same, and then you square 1, this will be a plus 1. Alright, so the cosine minus 1 will cancel out, leaving us with 1 over cosine squared x plus cosine of x, and then plus 1. So at this point, when we evaluate the limit, as x goes to 0, we plug in a 0, this gives us a 1, this gives us a 1, and then this is just a 1. So we end up with 1 over 1 plus 1 plus, plus 1. So we end up with 1 over 3 as our limit.